Okay, today, geometry class, we are going to talk about reflections. So I mentioned it briefly yesterday. Is a reflection a transformation? If you recall from yesterday, a transformation was, let me grab that definition so that's exactly what you had. You're probably already at that page and look back because here's how you guys are. Change in the position, shape, or size of a figure. So reflection, indeed, is a transformation that flips a figure perpendicular across the reflecting line and switches orientation, which I just realized we never talked about, is orientation. So orientation has two options. It's either clockwise or counterclockwise. So let me grab my other sheet because I have it from 9-1. So if we look at this one, I'm just going to pull this up right here. If you look at JKQ, when we look at JKQ, we would say this is clockwise. Okay. But when you look at J prime, K prime, Q prime, now it's going this way. So it's counterclockwise. And this is actually a reflection. So that's what they're talking about here, is if one is clockwise, its reflection is the opposite. It's counterclockwise. So what is the image of 3, 4 reflected across x equals -1? Okay, well, you got to know what x equals something is. What kind of line is that? When you have x equals something, or you have y equals something, there's certain types of lines that we have gone over multiple times, but it's one of those things that people just find hard to remember. Do you guys remember? Yeah, x equals is a vertical line, and y equals is a horizontal line. So when we have x equals -1, we have, I'll just draw my handy-dandy little coordinate plane there. And x equals -1 is, here's my x, -1's here. So that's x equals -1. Now I said, what is the image? Because that's the reflecting line. That's where it's going to get reflected over. So I got a graph P, 3, 4. 1, 2, 3, 1, 2, 3, 4. So there's 3, 4. And if you were going to reflect it across here, now if you were going to reflect across the y-axis where x equals 0, right here, that's a little bit easier. That would just be -3, 4. But it's not that case. It's across this line. So you have to always be counting and thinking how many spots to get over to the line. 1, 2, 3, 4 spots. And then you go 4 past that. 1, 2, 3, 4. So there's 4 spots between here and 4 spots between here. That's the reflection over that line. So what would that be? It's going to be -1, 2, 3, 4, 5. No. Wait, what was that one? I'm sorry, I just lost track of what I was doing. So there's 4 spots between here, and so I need 4 spots between here. So that's a -5, and then the 4 is the same, so up there. Okay, so there's your answer. P prime would be -5, 4. All right, go ahead and graph this next one here. And then we're going to figure out the image. your straight edge. And what do we call that original figure? Yes, a pre-image. Good. All right, so now we're going to go on and get the image for that. So we have to reflect it. We need to know across what, and it says across the x-axis. So I recommend using a highlighter so that that reflecting line, and I should have done that up here too, because sometimes we get these lines mixed up with the axis. So in this case, it is the axis, so we're going to reflect across the x, which is right there. So I'm going to highlight that line. And now, let's reflect. So we're going to count how many spots to the line and past it. So 1 and then 1. So P prime is right here. And then 1, 2, 1, 2. C prime. And A, wait, what the heck? That's B prime, not P. P is the pre-image. 1, 2, 3, 4. 1, 2, 3, and 4 right here. So that is your A prime. Use your graph paper and use your straight edge for your homework. Don't be sloppy. And that, of course, is your image. There's my little I for image. Do we need to label those coordinates? Let's see. Graph. What is the image of ABC? Reflect across. Okay, so no, we could just reflect it there and we're all done. Okay, so I want to talk about one other thing. I think, yeah, that's it for that one, isn't it? Okay, but let's look at page 555. It's a really good problem because it's talking here about minimizing the distance. Okay, so let's read it together. So hiking. Beginning from a point on Summit Trail, right here, a hiking club will build a trail to Overlook Park. Overlook's over here. And a trail to Balance Rock, which is over here. Working under a tight budget, the club members want to minimize the total length of the two trails. So they don't want to go, back here and back there. That's going to be longer than it has to be. Sorry, this is not real clear for some reason. Or maybe it's my eyes. How can you find the point on Summit Trail where the two trails should start? Assume the trail will be straight and that they will cover similar terrain. So we're not going through rocks or anything. So considering it's one point is here to here, hang on a second. I can put my pencil, which I don't see. Okay. We can't go through the rock. Okay. So and we went anyway because we wanted to come off of here. So yes, you could say, oh, I'm going to go right here and here, or right here and here, or right here and here. But remember, we want the one that has the shortest. So the shortest would be as if we went this distance. So you can't get any shorter than from here to here. Well, you can figure out what that distance is, and this is the cool part. If you reflect this point, the point that this is your starting point, if you take your destination where you want to end up and reflect it over the line you want to hit, you can reflect it over here, and that's what they did down here. I don't have to try it. They took this O and they reflected it over. So it's the exact same distance from here to here and here to here, and it hits it at a 90-degree angle there. And then when you reflect it, you use your straight edge, like that, to connect the beginning point to the ending point, and it will hit the trail in the exact right spot, and you would reflect it off and go back. Because if you look, this to here and this to here are the same. It's an isosceles triangle. So I wanted to have a straight line through, right? Well, that's the same distance as this. So I am getting the exact straight distance because of these two being the same. So, question is, I know it's a little confusing, but you'll get it. Your classmate began to solve the problem by reflecting R. We reflected R over this line. Would that work? And the answer is yes. So if she reflected it over here, then she could connect the point through. It's still going to go through this point. So what I want you to do is find the miniature golf sheet. I wanted to show you how to do that. If you haven't done that yet, or at least you could watch getting started on it. And then, I hope I have it. Oh, shoot. I don't think I have it. Well, I do have the answer key, so I'll show you how to do one of these. What you do when you are trying to reflect, and this is kind of fun, and this is, if there's time at the end of the year, what you might do is, if this is your ball, and you want to get it into here by hitting only one side, you take your two coordinates and you go to your destination, and you're going to reflect it over the wall that you're going to hit. So this is the wall you're hitting, isn't it? That's your reflecting line. And sometimes you have to extend it because it doesn't even fit on there. But then you can use, and your protractors will be easier because yours are smaller than mine. But you will literally set it up so that it's at a 90-degree angle. Look up here, 90. Right through the zero. Slide it over. And then you want to measure from here to here. So you're going to put a dashed line all the way through like I did. And then I'm going to actually measure from here to here, and then measure from here to here. So I would take, I'm going to use the inside of this here. These little millimeters are the easiest. And I say, oh, it's exactly 2 centimeters, or 20 millimeters. So now I'm going to just whip this around, and I'm going to measure this way, 2 centimeters. And that is how we get this point. Now you might say, well, how helpful is that? Well, it is helpful because now I can go back to where I'm starting, and I'm going to line up this with this. See, so I line it up, and then look at this. You draw until you hit the wall. It's not going to go through the wall, okay? It's going to reflect off the wall, hole in one. How cool is that? And when you do that, this angle here is the same exact angle as this. Mine actually looks a little different. I don't know why, but and that's how you would do it. So the next one, I'm going to let you try hole 2. That's similar to that one. And then there's one where you have to do 2 sides, and then 3. So I'll show you one of each. So if you go to hole number 3, again, you look at where the ball is, and you look at where it's going to end up. This is the one you're reflecting. And you have to kind of think about where the ball is going to go. The path it's going to go, if you're going to hit 2 walls, you're going to have to hit this wall, and go into the hole. So you want to reflect this coordinate off of the last wall that you hit. The last wall that you're hitting is that one. So then you would literally reflect it over. So you'd set up your protractor, and remember, when you set up the protractor, you got to make sure that 90 is lined up with this line all the way through. You draw your dashed line. Once you have your dashed line, then you measure. So I'll go in here now, and I'm going to measure from there to, it looks like it's about 1.4. Swing it around. 1.4, put my dot. Then, so I got that point, but we're not done yet, because if I'm hitting 2 walls, I have 2 reflections. So now, I'm going to take my new point. Okay, so I'm going to call this flag prime, because that's that flag prime. and I'm going to take F prime, and I'm going to reflect it over the next to the last wall you hit. What wall did you hit before you hit this yellow one? You hit this one right here, and this is what I was talking about when I was saying sometimes you have to extend it. In this case, you do. Just use a straight edge and extend the wall. So again, you're going to set it up this way now, 90 degrees. You're going to draw your dashed line all the way across. Then you're going to measure from here to here, about 5.9. I'm going a little faster now, and you're going to measure from here to here, about 5.9. And then now you've got F prime. So when you begin, you're going to start at the B, the ball. You're going to line up the ball with your last coordinate that you have here. So you're going to line it up with this. You're going to draw. It's going to hit the wall. You stop. You line that new one up with that other F prime. You draw. You hit the wall. You stop. And you line it up with the hole-in-one. Again, these are the same, and these are the same. So, feel free to replay any of these if you need help with that. You try 4. I'm going to do 5. 5 is a little brutal. They're kind of fun, really. Don't you think so? Alright, so we have to show how to determine the path of a ball B. So we hit 3 sides. So here's B. So first, again, you have to kind of figure out where you're going. So I'm like, okay, I'm going to go hit this, and this, and this, and in. So remember, you're working backwards. So the first thing I'm going to do is take the F, the flag, and reflect it over the last wall that we hit, which is that one. Can't even see that. That one. So again, you line it up, you get the 90 degrees set, you draw your dash line. Then you're going to measure from here to here, and from here to here, and get F prime. There it is. Now you take your new F prime, and you're going to go over the next to the last wall. So what do you hit before you hit this wall? Backtrack. This wall. Oh dear. So we're going to go over this wall now. So be careful you don't get them mixed up. So you're taking this point over this wall. So put your 90 right here, and you're going to dash a line all the way through. Dash a line all the way through, and now I'm going to measure. I'm going to measure from here to here. 4.4, and then I'm going to measure down here, 4.4. And there, right there, is my F prime, right here. Oh, right here. It'd be helpful if I kept it on the screen. Now I have to reflect this over the next side I hit. So what side do we hit then? Over here. So that one has to go and get extended, this side, all the way down, so that we can reflect this over the yellow. So again, lining up the 90 with the yellow, extending, drawing your line, measuring, and I get F prime way the heck over here. So let me do a bigger view of this. So I've got F prime. So I took reflected, then I took this and reflected it over here. Then I took this and reflected it over here and got this. Now it's time to draw the path. So you start again with the ball, and you line up with the last one you just did. Draw a line, hit the wall, stop. Go to the next one, F2. Draw a line, hit the wall, stop. Line it up with the F1. draw a line, hit the wall, stop, and into the hole. Same, same, same. We're reflecting and reflecting and reflecting some more. So, I hope that helped. Give it a try though. I hope it goes well. All right, bye-bye.